So we are going to start remaining questions of exercise 4.2. So we'll do from question number 11. So just check question number 11. What is it? So question number 11 is prove that answer 11. I'm showing first question. So we have to prove that A minus B minus C 2A 2A 2B B minus C minus A 2B 2C 2C C minus A minus B. This should be equals to A plus B plus C whole cube. So this is our left hand side. So we'll mark it LHS. Now if column wise will add or row wise will add, then what we'll get? Right? So if row wise if you add, are you getting A plus B plus C? If you will add column wise, then we are not getting. That means row wise R1 goes to R1 plus R2 plus R3. Right? Then we'll get A plus B plus C. Then A plus B plus C. Here also A plus B plus C. Then 2B, B minus C minus A, 2B, then 2C, 2C, C minus A minus B. So write down this. Now taking common A plus B plus C from R1. Taking common from A plus B plus C. Taking common A plus B plus C from R1, then what you will get? A plus B plus C outside, then here 1, 1, 1, then 2B, B minus C minus A, 2B, 2C, 2C, C minus A minus B will get. Now if any row all elements are 1, then make here 0 and here 0. Then you will observe other two factor also will be common. Okay. Now use operation C2 goes to C2 minus C1. Then we'll get A plus B plus C. Then 1, 2B, 2C, here 0. And if you subtract these two, then what you will get? this minus this. So minus you can take common. A plus B plus C will come. And this minus this, you will get 0. Now C3 minus C1. Then you will get here 0. 2B minus 2B equals to 0. And this minus this. So here also minus you can take common. A plus B plus C. After that, since these two are 0, then only we can take minor of 1. So A plus B plus C, then minus A plus B plus C, 0, 0, minus A plus B plus C. Now break it. Then A plus B plus C, or here you will get A plus B plus C whole square. So we are getting A plus B plus C whole cube, and this will be RHS. Okay, so understood this?
So what you did in the last step?
In last step means here in this step.
Yes, sir.
Here I have here minor of 1 only we have to take, since this element and this element 0. Okay, so minor of these two elements will not come, only minor of 1 will come. So minor of 1 is minus A plus B plus C, 0, 0, and this is minus A plus B plus C. After that, if you cross multiply, then you will get A plus B plus C whole square. Minus 0, so no need to write. So A plus B plus C whole square. Now understood?
Yes, sir, got it.
Sailuddin understood?
Yes, sir.
Okay, fine. Now, next question. So I am changing this. Okay. Now, next question we'll do. Question number 11, second, also same type. That's why I'm not doing. Now, we'll do question number 12. So, question number 12, these questions already came in board exam, right? So, I am writing this question. Answer 12. So consider LHS, that is equals to 1 x square 1 x, then x square 1. We have to prove this is equals to 1 minus x cube whole square. So here in many way we can do these questions, but I'm showing within a 2 steps you will get this answer. Okay, so very easily you will get this answer. Here I'm using R3. R3 goes to x into R3 goes to R3 minus x into R1. Can you use or not this operation? In place of number, any variable also you can consider. So R3 minus x R1 also we can consider. Any confusion, Sailuddin?
No, sir.
Sure. Nargis, any problem?
No, sir.
Okay. Now, what is the benefit of this? That in this, only using this, only one operations will get the answer if you use this. So here we are getting 1 x square 1 x. So multiplying x, and if you subtract, this is 0. If you subtract, then this is also 0. And if you multiplying x, if you subtract, then it will be 1 minus x cube. Right? Understood? Now we can take, if we break it, since these two elements are equal, then we can write 1 minus x cube multiply by minor of this. That means third row and third column will be deleted. Then 1 x square 1. Now any confusion here? Since these two elements are equal, any row we can use, any column we can use to expand a determinant. If third row two elements are 0, then this element 1 minus x cube into minor means 1 minus x cube lies in third row and third column. That you will remove. Remaining part will be the minor of this element. So 1 minus x cube into minor of 1 minus this element. So we'll get 1x square 1. Now break it. 1 minus x cube cross multiply, then we are getting 1 minus x cube. Then we are getting final answer, that is 1 minus x cube whole square. So easily we are getting RHS. But if you use R1 plus R2 plus R3 or C1 plus C2 plus C3, then more step you have to do. But your choice, because here the only using one operations we are getting our result. So you have to remember this. So any question?
Sir, how we will know that which minor we have to take?
Okay. Any here though we can observe these two elements are 0. Right? So we can use any row or any column to break a determinant. Now here third row we can observe first element and second element are 0. So we'll take third row to expand it, not first row. Now in 4.4 you will know about this. Using any row or any column we can expand a determinant. So here we are using third row since these two elements are equal. Understood, Nargis?
Okay, sir.
Because
Yes.
these two elements are 0, that's why we are taking third row. But here if in first row two elements are 0, then we take element of first row. If in any column two elements are equal, okay, then we'll take that third element and its minor to break it. So any row or any column we can use to break a determinant. Understood?
Yes, sir. Yes, sir.
So
Got
have you
it.
written this?
Yes,
Select.
sir.
Okay. Now I'm changing. Now question number 13. Or take a screenshot. Now question number 13. These two questions are little bit different. Okay. So answer 13. LHS equals to 1 plus A square minus B square 2AB minus 2B. Here 2AB 1 minus A square plus B square. Here 2A. Then here 2B minus 2A 1 minus A square minus B square. right? So any row or any column if you'll add, or any two rows or any two columns if you'll subtract, we are not getting directly 1 plus a square plus b square, this factor. Okay, but up to question number 12, what we observe, either we have used R2 minus R1, R3 minus R1, or we have used C2 minus C1 or C3 minus C1, or R1 plus R2 plus R3, or C1 plus C2 plus C3. But here we are not getting, if we'll add all three rows or all three columns or any two rows, if we'll subtract, then also we are not getting that factor. So we have to observe right hand side also. So what is the factor in right hand side? So one technique here I'll use. First, I'll take, I'll multiply here, I'll multiply B in third column, and after that I'll subtract. So if you want to multiply B with third column, then divide B, then you can multiply with any row or any column that B. So I am multiplying this B with C3. So 1 plus a squared minus b squared, 2ab, then 2b, are here 2ab, 1 minus a squared plus b squared minus 2a. Here if you will multiply b, then what you will get? Minus 2b squared. Here 2ab, are here b into 1 minus a squared minus b squared. Right. Now R1 minus R3 if we'll do. So R1, sorry, C1, not R1. C1 goes to C1 minus C3. Then what will happen? 1 by B, 1 plus a squared minus b squared. Or here if you will subtract, then you will get here 1 plus a square plus b square. Here if you will subtract, then 0 will come. And here if you will subtract, then b will be common, right? And you will get 1 plus a square plus b square. Here 2ab, 1 minus a square plus b square, here minus 2a. Here minus 2b square, 2ab, and here b into 1 minus a square minus b square. Now after that, taking common, taking common 1 plus a square plus b square from C1. So taking common 1 plus a square plus b square from where? C1. So one factor we got, 1 by b, 1 plus a square plus b square. Then here we are getting 1, here we are getting 0, and here we are getting b. Here 2ab, 1 minus a square plus b square minus 2a. are here minus 2b square, 2ab are here b into 1 plus 1 minus a square minus b square. Now this 1 by b multiply with c3, 1 plus a square plus b square. So 1 0 b, then 2ab 1 minus a square plus b square minus 2a, or if you multiply 1b here, so we'll get minus 2b. Here you will get 2a, or here you will get 1 minus a square minus b square. Now multiply a with c3 and then subtract. So here I'm not using this directly, I'm using operation. So c2 goes to c2 plus a into c3. That also we can do. Here also we can do like that operation. So 1 plus a square plus b square. Then here 1 0 b. Achha, here if you add, then what you will get? Here 0 you will get. Multiply here a and then add. Then what you will get? 1 plus a square plus b square. Here multiply a and then add. So here we take common minus a. Then you will get 1 plus a square plus b square. So here minus 2b, then 2a, 1 minus a square minus b square. After that again take common 1 plus a square plus b square from c2. Now taking common 1 plus a square plus b square from c2. Then you will get 1 plus a square plus b square whole square, and here 1 0 b, here 0, here 1, here minus a, and here minus 2b, 2a, 1 minus a square minus b square. Now for third factor, just break it. Open this. So here 1 plus a square plus b square whole square we got. Now break 1 into minor of 1. So it will be 1 into 1 minus a square minus b square, or here plus 2 square plus 2a square. Then 0 no need to take, or here minus 2b into minor of minus 2b, that will be here 0 minus b, 0 minus b. After that just break it. 1 plus a square plus b square whole square. Then here we are getting 1 plus a square minus b square, or here we are getting plus 2b square. So 1 plus a square plus b square whole cube we got. This is RHS. Okay, take a screenshot quickly. Done? Sailuddin?
Yes, sir. Done.
Okay. Now, last question of this exercise, that is question number 14. This is also little bit different. Okay. So, answer 14. LHS equals to a square plus 1 AB AC AB B square plus 1 BC CA CB C square plus 1. Right? Acha, right hand side, if you observe, only one factor, 1 plus a square plus b square plus c square. Here also you will observe R1, R2, R3 if you add, nothing you will get. Even C1, C2, C3 if you add, then also you are not getting. Any two rows or any two columns if you will subtract, then also you are not getting. That means something differently you have to think. So here what we'll do, we'll take A common from R1, B common from R2 and C common from R3. Understood? So taking common A from R1, B from R2, C from R3. So A, B, C are common. So from here we have taken A common, so it will be A square plus 1 divided by A, right? Okay. And here we'll get B, here we'll get C. From here we are taking B common, so we'll get here A, here B square plus 1 upon B, or here C. From here we are taking C common, so here we'll get A, here we'll get B, here we'll get C square plus 1 upon C. Right? Achha. Now, this ABC multiplied column wise. That means row wise we have taken common and we'll multiply column wise. So multiply A with first column. Then we'll get A square plus 1. Then this is A square, this is A square. B multiply with C2. Then we'll get B square. Then B square plus 1. Or here B square. And C multiply with third column, then we'll get C square, then C square and C square plus 1. Now think, check right hand side. If any row or any column, if you'll add, will you get this factor 1 plus A square plus B square plus C square? Row wise you will add or column wise you will add? Tell me, Saluddin.
Sir, column wise.
Yes, you have to add column wise. That means C1 goes to C1 plus C2 plus C3. Then first column you will get 1 plus A square plus B square plus C square. Then 1 plus, here also 1 plus A square plus B square plus C square. Here also 1 plus A square plus B square plus c square. Here b square. Now b square plus 1. Here b square. Here c square. This is c square. This is c square plus 1. After that, taking common from, now take common. Taking common 1 plus a squared plus b squared plus c squared from C1. So 1 plus a square plus b square plus c square common. Then you will get 1, 1, 1, b square plus 1, b square, c square, c square, c square plus 1. Since first column all element 1, so use row operation. R2 goes to R2 minus R1. R3 goes to R3 minus R1. Right? Then we'll get 1 plus a square plus b square plus c square. And here 1 b square c square. Here 0. If you subtract this, then 1 you will get. Here 0. Here 0. Here 0. Here 1 you will get. Since these two elements are 0, then you will take minor of 1 only. So a square plus b square plus c square will get 1, 0, 0, 1. So this value is 1. So final answer 1 plus a square plus b square plus c square, and this is RHS. So in this question, directly you will not break. Directly if you break, then marks you will not get. In this kind of questions, it will come in examination. So you have to use property. After that, we can do it. So understood? Okay. Okay, Sailuddin, understood?
Yes, sir. Understood.
So our 4.2 all questions finished, right? So I'm ending video here.